Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we will be learning about literal equations. Let's get started. So, literal equations are equations that involve more than one variable. So, like the variable is basically like x or y or z or any other like letter that's not a number. And so an example of a literal equation could be something like this, where there are two variables involved, and in this case, their two variables are x and y. So 6x plus 7y is equal to 24 would be a literal equation. Another example could be something like this. This equation says a plus 3b minus c is equal to d. This equation has four variables, so they don't only have to have two variables, they can have more than one. So the variables in this one is a, b, c, and d. So both of these are examples of literal equations. Let's move on to learn how to solve literal equations when they involve constants. So in general, when you are solving a literal equation, they will usually give you a variable to solve for. So like solve for x, solve for y, solve for a, solve for b, something like that. And so what you really want to do when you're solving with constants is to rewrite the equation to solve for the given variable. So an example over here is, let's say that we had this equation that says 6x plus 8 is equal to 4 plus 3y. And it wants us to solve for x. So we would solve this like we would any other equation. And we're just going to first want to get this x term isolated alone. So to do that, I'm going to subtract 8 from both sides, right here. And I'm going to work this out. So we have the 6x right there, and then positive 8 minus 8 cancels out, so that just leaves us with 6x, which is equal to 4 minus 8, which is negative 4, plus 3y. So we're going to divide this side by 6, and then we're going to divide both terms on the right also by 6. And so 6x divided by 6 gives us just x, which is equal to negative 4 over 6, which can be simplified to negative 2 over 3, plus 3y over 6, which can also be simplified to just y over 2. And so this right here would be our final answer. So now that we know how to solve with constants, let's move on to solving without constants. So when we are solving without constants, what we want to do is treat the variables that you aren't solving for as constants. And so let's say we have this equation right here now that says v is equal to L times W times H. And it wants us to solve for W. And so normally when you have variables, you try to isolate that variable on one side on its own. But since this equation has multiple variables, you can't get each variable its own side. And so what you're going to do is whatever variables you aren't solving for, you're just going to treat them like constants. So let's start solving for this. We want to solve for W, and so all we have to do is divide this side by L and H to leave us with just W alone, and also divide the other side by L and H. And so this will give us V over L times H is equal to, and then LWH divided by LH will give us just W because the LH on the top and the LH on the bottom cancel out. So this leaves us with this, where we can now switch around the way this is written, and instead of saying V over LH is equal to W, we can make it easier to read and write W is equal to V over LH. And that will be our final answer. Now that we sort of have an idea of how to solve literal equations, let's move on to the back to solve some practice problems. So on this page, we have our literal equations practice, and we're going to go to problem 1. Problem 1 says solve the equations for x. So the variable we need to solve for is x. On our first one over here, our first step is always just to get the x term alone on one side. So to do that, for this one, we have to subtract y from both sides to get us just the x term alone. So 5x, and then the y's cancel each other out, is equal to 12 minus y. Now all we have to do is get this x term alone, and so we are going to divide this side by 5 and then divide the other side by 5 too. So 5x divided by 5 gives us x, which is going to be equal to 12 minus y over 5. And so this is going to be our final answer. So x is equal to 12 minus y over 5. On this problem, however, we could have taken another approach in doing this. We could have, instead of dividing the entire 12 minus y by 5, we could have divided 12 over 5 and then divided the negative y over 5. This would ultimately give us the same answer, and it's just another way that we could approach this problem. For our next one over here, we want to get this negative 18x term alone, and so we're going to subtract y from this side, subtract y from the other side as well, and so minus 7y minus y gives us negative 8y, which is equal to, and then y minus y is equal to 0, so that's nothing over there, and that leaves us with negative 18x. Now what we want to do is just get the x term alone, so divide both sides by negative 18 right here. And so we divide negative 8y by negative 18, and since we're dividing a negative by another negative, our answer will be positive. So that's going to be 8y over 18, which is going to be equal to negative 18x divided by 18 just leaves us with x. But this is not our final answer because this can be simplified more. And so instead what we're going to do, instead of writing this as 8y over 18, you can see that if I divide 8 by 2 and if I also divide 18 by 2, that can give us 4y over 9 instead of 8y over 18. So this is now simplified, and all of this is going to be equal to x. So we just have a simplified version now, and so this is going to be our final answer. Next up, we have this equation over here, and if you look, both of these equations are divided by something. They're both fractions on both sides. And so what we want to do is first get rid of the fractions on both sides. So instead of just multiplying this side by 7 and then this side by 7 to get rid of this 7 first, and then multiplying both sides by 2 again to get rid of the other fraction, instead what we're going to do is we are going to multiply both sides by the same number. And that number is going to be the least common multiple of both of the denominators of these fractions. And so what this is going to do is it's going to cancel out the fractions for us in a really quick way. So the least common multiple is basically the earliest number that is divisible by both of the denominators. And so the least common multiple of 7 and 2 is actually 14. So we're going to multiply both sides by 14 to try and get rid of both of these denominators right here. And so when we multiply this, we can get rid of this fraction by dividing 14 by 7, which leaves us with just 2. So that means we have the 2 up here, which is going to be multiplied by the numerator. So the numerator is not an actual constant here, it's a binomial. And so we're going to put that in parentheses, and we're going to say 2 times x minus 5. And so it's the same thing on the other side. And we're going to divide 14 by 2, which gives us just 7 on the top. And since the numerator is a binomial, we're going to multiply this 7 that we got from 14 divided by 2 by this entire binomial. So that's 3y plus 3. Now we're going to distribute this, and so we're going to first multiply 2 by x, which gives us 2x, times 2 times negative 5, which gives us minus 10. So 2x minus 10 is equal to, and then 7 times 3y is 21y, plus 7 times 3, which is just 21. And so now we have this equation and we're going to solve it for x. And so we're going to get this 2x term on its own by adding 10 to both sides, right here. And so now we have 2x is equal to 21y plus 21 plus 10, which is 31. And so now the last step is to divide by 2 to get that x just completely alone. So we're going to divide the left and the right side both by 2. And so 2x divided by 2 leaves us with just x, which is going to be equal to 21y plus 31 all over 2. And that is going to be our final answer. Now that we've solved all of these equations for x, we're going to move on to problem number 2. Problem number 2 says to solve each of the equations for y. So what we're going to do for this first one is get this yx term alone. You may be wondering why we're getting the yx term alone and not just the y. It's because the yx term has the y variable inside of it. And we can't really divide out x yet until it's alone on one side. So we're just going to get this yx term alone. And to do that, we're going to add 5 to both sides. And so yx, and then minus 5 plus 5 gives us just 0, which is nothing, is equal to x plus 5. Now we can divide both sides by x to just get the y term alone. So yx divided by x on this side, and then both terms on this side are going to be divided by x. And so yx divided by x leaves us with just y, which is going to be equal to x divided by x is just going to give us 1 plus 5 over x. And since this can't be simplified any further, this right here is going to be our final answer. For our next one, the only term with a y variable in it is the 4yx, and so we're going to try to get that alone. To do that, first we're going to subtract 2x from both sides right here, and so that's going to give us 4yx, and then 2x minus 2x gives us just 0, so we don't need to write anything, which is going to be equal to z minus 2x. Now to get this y alone, we're going to divide the left side by 4x because those are the only two variables that are being multiplied by the y, and we're also going to divide both terms over here by 4x. And so 4yx divided by 4x leaves us with just y, as the 4's and the x's cancel each other out, which is going to be equal to z over 4x minus 2x over 4x. Now this is not our final answer because it is not fully simplified. If you look on the right of the right side of the equation, 2x divided by 4x could be simplified to just 1/2. And so we're going to do just that, and we're just going to simplify. And so it's going to leave us with y is equal to z over 4x minus 2x divided by 4x, which is just half. And so now this is our final answer. Y is equal to z over 4x minus half. For our last one on this set, we have to first distribute to be able to get the y term alone. And so we're going to do just that, and we're going to multiply negative 4 by negative x is positive 4x, and then negative 4x times negative y is positive 4y. And that's all going to be equal to z. Now we can get this y term on its own by subtracting 4x from each side. So minus 4x and minus 4x on the other side as well. And so 4x minus 4x is just 0, plus 4y is equal to z minus 4x. Now the last step is just to divide this side by 4 to get the y alone. So you divide that by 4 and both terms on the right also by 4. And so 4y divided by 4 leaves us with just y, which is going to be equal to z over 4 minus 4x over 4, which can be simplified to just x. And so this right here, y is equal to z over 4 minus x, is our final answer. Now let's move on to problem 3. Problem 3 says to solve the following equations for the given variable. So if we look at our first one, the equation is a is equal to pi r squared, and it wants us to solve for pi. And so we have our equation right here, and we want to solve for pi, and we just have to get pi alone on one side. And to do that, all we have to do is divide the side by r squared to just get pi alone. And we're going to divide this side by r squared and also the other side by r squared. And so we end up getting a over r squared is equal to pi. Or instead of writing it like that, we can sort of switch it around and write pi is equal to a over r squared. And so that is our answer for this one. Our next one says y is equal to mx plus b, and we want to solve for m. So again, we have our equation right here. And to solve for m, first we need to get this mx term alone. And so to do this, we're first going to subtract b from both sides. And so that's going to give us y minus b is equal to mx. And so now all we have to do to get m alone is divide this side by x, and then also divide the other side by x. And so we get y minus b over x is equal to mx divided by x, and the x's cancel each other out, so we get just m on this side. And to make this sort of easier to read, we can write m is equal to y minus b over x. And that is our final answer. For our last one, the equation is v is equal to 1/3 pi r squared h, and it wants us to solve for h. So in our equation right here, we have a fraction that we want to get rid of. And so to get rid of the fraction, remember we have to find the least common multiple of the denominators that we are using and then multiply both sides by that number. In this case, we only have one number instead of two, and so the least common multiple of only one number would be that number, and in this case it is 3. So we are going to multiply this side by 3, and then multiply this side also by 3. And so we're going to end up with 3v is equal to, and then 3 times 1/3 cancels out and just leaves us with 1 times pi r squared h. Now that we have this, we just want h alone, and so we can divide this side by pi r squared to just get the h alone, and divide the other side also by pi r squared. And so this is going to give us 3v over pi r squared is equal to, and the pi r squares cancel each other out, which is just going to leave us with h. And we can also rewrite this as h is equal to 3v over pi r squared. And so that right there is our final answer for this one. H is equal to 3v over pi r squared. So that's it for today, guys. If you like my videos, please like, subscribe, and share. And be sure to comment down below any other Algebra 1 topics you would like me to do, or any questions that you have on this video or on other videos. Also, be sure to follow me on Facebook and on Instagram from the description below. Thanks for watching. See you next time. Bye!